Hello YouTube family, welcome back. We solve for the value of x given this nice exponential equation, which is 2 raised to power x plus 4 raised to power x plus 8 raised to power x is equal to 14. So what is the value of x? Solution. Now we have 2 raised to power x plus 4 raised to power x plus 8 raised to power x. This is equal to 14. Okay, so here we can write 4 as 2 raised to power 2, that is 2 squared raised to power x, plus 8, we can write 8 as 2 raised to power 3. So we can have 2 cubed raised to power x. This is equal to 14. Okay. Now from here, you're going to have 2 raised to power x plus 2 squared raised to power x plus 2 cubed raised to power x. Now this is 14. 14, you take 14 on the left hand side so that you'll have negative 14. This is equal to 0. Okay. Now from here we can have 2 raised to power x plus 2 raised to power x multiplied by 2 plus 2 raised to power x raised to power 3 subtract 14. This is equal to 0. Okay. Now we have 2 raised to power x raised to power 2 simply because of using this indices property that if you have a raised to power n multiplied by m, this can be expressed as a raised to power m raised to power n. Is the same thing. A raised to power n raised to power m is the same as a raised to power n raised to power n. Okay, so we can express this, the property that you have used here, so that now from here we can say let 2 raised to power x be k. Okay, now so that we're going to have k plus k, this is k raised to power 2 plus this is k raised to power 3 subtract 14. This is equal to 0. Okay, now from here we'll have k plus k raised to power 2 plus k raised to power 3 subtract 14. 14 can be expressed as 8 plus 4 plus 2. This is equal to 0. Okay, so that we're going to have k plus k squared plus k cubed subtract 8 can be expressed as 2 raised to power 3. Then we have negative times positive 4. This is negative 2 raised to power 2. Then negatives times positive 2. This is negative 2. This is equal to 0. Okay. Now from here, we can be able to combine, that is the exponentials with the same power. So we are going to have k subtract 2. We will have k subtract 2 plus k squared. Okay. Subtract 2 squared plus k cubed subtract 2 cubed. This is equal to 0. Okay, so now from here we have 3 parts. This is the first part. Okay, we have the second part, and now we have the third part. Okay, now from here, as you can see that the second part, this is the difference of 2 squares, that is k squared subtract 2 squared. This is in the form of a squared minus b squared, which is the difference of 2 squares, which is expressed as a plus b, a minus b. Okay, so we can be able to have k squared subtract 2 squared as k plus 2 and k subtract 2. We can be able to express that part as that. Okay, so let's proceed. The third part, for the third part we have k cubed subtract 2 cubed, which can be expressed as k subtract 2, then k squared plus 2k plus 2 squared, which is equal to 4. Okay, so this is the difference of 2 cubes expressed as a cubed subtract b cubed which is the same as a subtract b, a squared plus ab plus b squared. Okay, so this is what we have. Okay, so let's recombine the three parts, part 1, part 2, and 3. We'll have k subtract 2 plus, we have here k plus 2. This is k plus 2, k minus 2, plus we have k subtract 2. Then we have k squared plus 2k plus 4, everything equal to 0. Okay. Now from here we factor out, you can see k minus 2 is common in part 1, 2, and 3. So we factor out k minus 2. Okay. So that we're going to have, this is 1 plus, now here we have k plus 2. Okay. Plus k squared. This is k squared plus 2k plus 4, everything equal to 0. Okay, so you can be able to see that clearly the first value of k, which is k subtract 2, is equal to 0. That means that k is equal to 2. That is k1. You can call this one k1 is equal to 2. Okay, so let's deal with the what is in the parentheses. We have 1 plus 2 plus 4, which is equal to 7, plus k plus 2k, this is equal to 3k, plus we have k squared. Okay, we have k plus 2k, which is 3k. Okay, so we have plus k squared, this is equal to 0, which you can rearrange as k squared plus 3k plus 7, this is equal to 0, which forms a quadratic equation. Okay, now we have a quadratic equation which is k squared plus 3k plus 7, whereby a is equal to 1, and then b is equal to 3, and c is equal to 7. Okay, now from here we have that we can be able to determine the discriminant value, okay, which is expressed as b squared minus 4ac. Okay, we want to check if we have the real roots for our quadratic equation, or rather we have the imaginary roots. Okay, now let's substitute the values here. B squared, this is 3 squared, subtract 4 times a, which is 1, times c, which is 7. So this is 9, subtract 28, so that we're going to have negative 19, which is less than 0. So that means that here we have two complex roots. We have two complex roots which are imaginary roots. Okay, these are imaginary roots. All right, which can, from our quadratic equation, we can be able to determine the discriminant value, which actually will tell us do we have the real root or the imaginary root, which is expressed as b squared minus 4ac. Let's check if we have a real root on imaginary. So from our case here, we have b squared minus 4ac is less than 0. So if you substitute b squared, you're going to have negative 19, which is less than 0. And in this case, we have two complex roots, or rather the imaginary roots. Imaginary roots. Now we can solve for the values of, remember from our quadratic equation, which is expressed as k squared plus 3k plus 7, this is equal to 0. So we can be able to determine the values of these imaginary roots by using the quadratic formula, which is expressed as negative b plus or minus the square root of b squared minus 4ac, divide everything by 2a. Okay, so let's substitute the values of a, b, and c, so that we're going to have negative 3 plus or minus the square root of b squared minus 4ac, which is actually negative 19. This is negative 19 divided by 2 times 1. Okay, this is equal to negative 3 plus or minus the square root of 19 can be expressed as 19 times negative 1 divided by 2. Okay, now from here we can express this as negative 3 divide by 2 plus or minus the square root of negative 1. This is equal to I. So you have I square root of 19 divided by 2. Okay, so that means that we're going to have two possible values of k. That is, k2 can be expressed as negative 3 over 2 plus I square root of 19 over 2, or k3 can be expressed as negative 3 over 2 subtract I square root of 19 divided by 2. Now these are the two of these. These are complex roots. Complex roots, which actually will these one are not going to be, in other ones, these one are not going to be applied. These are not applicable from our part. We will not be able to solve for the value of x given this imaginary root. Okay, so because if we determine that is the logarithm of k2 and k3, this is going to give you it's actually undefined. So we only have, that is a real root, one real root, okay, one real root that we express as k, which is k1, which is equal to 2. Okay, now from here, if you recall, we said that 2 raised to power x be k. Okay, and you can check that our k is equal to 2. Okay, so we have 2 raised to power x is equal to k, which is equal to 2. Okay, so that means we have that 2 raised to power x is equal to 2. This is 2 raised to power 1. Okay, now as you can see, applying the laws of evidences, that is a raised to power n is equal to a raised to power n, and given that the bases are common, so the exponents also are equal. The exponents are equal, that is n is equal to m. So that means that the value of x is equal to 1. Okay, the value of x is equal to 1. Now we have that x is equal to 1. Okay, and you can see we can be able to verify. Let's verify if this value of x is equal to 1 satisfies the equation. Remember, we end 2 raised to power x plus 4 raised to power x plus 8 raised to power x. This is supposed to give us a value of 14. Let's substitute the values of x, which is the value of x, which is 1. We're going to have 2 raised to power 1 plus 4 raised to power 1 plus 8 raised to power 1. This is equal to 14. And this is 2 plus 4 plus, this is actually 14, which is equal to 14. So that's the left-hand side is equal to the right-hand side. And that shows that the value of x, which is equal to 1, actually satisfies the equation and is the solution. Okay, so thank you for watching and kindly subscribe.